dry powders have a yellow star on the extinguisher label. Med-LX powder is the most common dry powder. It is non-toxic, non-abrasive, and non-conductive. Heat from the fire causes the powder to form an air excluding a crust. It does not cling well to vertical surfaces. Most dry powders are useful on small fires because they withdraw oxygen and lower the temperature of the burning metal below its ignition temperature. Approved halogenated agents such as halon 1211 or halitron 1 are colorless, odorless, and non-conductive. They completely evaporate and leave no residue. Halogenated agents will produce acid gases when discharged onto a fire. To avoid exposure to fire and agent byproducts, full PPE should be worn. Halogenated agents are the first choice for aircraft engine and avionic fires. Note that they lack sufficient cooling and vapor sealing effect. Therefore, reignition is a possibility. Carbon dioxide, or CO2, is colorless, non-flammable, and odorless. It displaces air, smothering the fire. Carbon dioxide can produce unconsciousness and death in high concentrations. Choosing the right extinguishing agent for airport fires requires knowing which airport materials fall into which fire class. Class A fuels are ordinary combustibles that leave ash when they burn. Class A fires on aircraft include burning seats, interior finish, luggage, cargo, tires, and passengers. Interior fires are often caused by post-crash fuel spills. Ordinary combustibles require cooling and quenching to extinguish. Foam is the first choice for fuel spill and interior fires, but water can be used in certain situations. If the vehicle is equipped with a piercing nozzle, approved halogenated agents such as halon 1211 or halitron 1 may be discharged into unoccupied aircraft compartments. The greatest fire hazard at airports is aircraft fuel, which is flammable liquid or gas, a Class B material. Foam is the agent of choice for Class B liquids, since it not only extinguishes the fire, but prevents reignition. However, foam is ineffective in fighting pressure-fed gas fires. Dry chemicals and clean agents will extinguish Class B liquid fires, but will not prevent reignition. Dry chemicals and clean agents are the agents of choice against Class B gas and three-dimensional fires. Class C live electrical or avionic equipment can present an electrical shock hazard if the wrong extinguishing agent is used. Water and foam are not recommended on electrical equipment because they can cause as much damage as the fire itself. While dry chemicals are Class C rated, they can be highly damaging to equipment. Carbon dioxide and approved halogenated agents such as halon 1211 or halitron 1 are the recommended agents for Class C fires. If power to the equipment can be cut, the Class C fire will likely shift to a Class A fire. Class D combustible metals burn at much higher temperatures than Class A or B materials and can be difficult to extinguish. A Class D fire requires a Class D rated dry powder agent except in very specific applications. No other extinguishing agents work on metal fires. Most Class D fires require copious amounts of agent or complete covering of the burning metal. Major ARFF vehicles are designated by the quantity of water they carry, from 1,000 to 4,500 gallons. Combined agent vehicles simultaneously apply two different agents. One is usually a pre-mixed solution of AFFF. The other is a dry chemical or clean agent. The Federal Aviation Regulations require a complementary agent system on ARFF apparatus. This is typically dry powder or positions along the edge of a liquid spill to cover the entire pool. Continue to apply foam until it spreads across the entire surface of the fuel and the fire is extinguished. Use the roll-on method only on pools of liquid fuel, ignited or unignited, on the ground or pavement. In the base of the fire method, firefighters supply ARFF at a 0-degree base of the fire angle to maximize agent effectiveness and minimize extinguishment time. Applying foam in a sweeping motion from a bumper turret or handline is an effective use of base of the fire method. If possible, approach and begin foam application from upwind and uphill. The least desirable location is directly downwind. When applying foam on fuel, never aim or plunge the foam stream directly into the fuel spill. That will stir up fuel vapors and greatly reduce the foam's effectiveness. The fire must be completely extinguished before foam application can stop. Apply dry chemicals by directing agent at the base of the fire and sweeping the nozzle back and forth. Charge and test the system by discharging the agent before approaching the fire from upwind. Check range by discharging small bursts at the fire. Start the initial application from as far away as possible. Hand lines from large wheeled extinguishers and truck-mounted systems have significant nozzle pressure. Brace yourself and have someone back you up. Directing agent into burning fuel at close range agitates and intensifies fire intensity. Sweep your discharge pattern from side to side beyond the outer edges. Drift a cloud of dry chemical through the entire area in flames. Do not stop application until fire is extinguished. When applying approved halogenated agents, such as Halon 1211 or Halotron 1, follow the same initial guidelines as with dry powder, including testing extinguisher and approaching upwind. Apply agent in front of the leading edge of the fire and sweep the stream from side to side beyond the outer edges of the fire. The rate of sweeping should be slightly faster than a dry powder application. Continue sweeping while pushing the fire back and do not stop application until the fire is completely extinguished.